All right, class. If you would please get out this yellow paper that you see on the screen. We're going to be looking at this, and we're going to do some simplifying of algebraic expressions. Before we get into simplifying some of these big beasts here, let's go to the back and just write a couple vocabulary words. We'll talk about distributive property, which is on the screen a little bit later, but we need to take this blank space and write a couple things here. So here we go. All right, first of all, let's talk about this word. We're simplifying by combining like terms. So first of all, the word terms. What does that mean in algebra? Well, it simply means terms are parts. They're parts or pieces. It's spelled right. Please copy this down. Of an algebraic expression. Parts or pieces of an algebraic expression separated by add, this, and subtract symbols. So parts or pieces of an algebraic expression separated by add and subtract symbols. Terms always include a number, sometimes a variable, and the sign in front of it. So terms always include a number, sometimes a variable, and the sign in front of it. Now, I'm going to just highlight this part right here because this is super important. This seems to be where most students get hung up, that terms are parts and pieces of algebraic expressions and equations. They include the sign in front of it and all the rest of this stuff. We'll talk about what that means in a minute. Then there's one more expression you need to write, and that is called like terms. One more definition here. Like terms. Like terms refers to terms, remember that means parts, that have the same variable or non-variable. Make sure you have these written. If you need to pause for just a minute, you can, but terms that have the same variable or non-variable. So we're talking, another way to say it is the same family members. Okay. So we're going to be talking about how to take terms or parts and pieces and combine them together when they're alike and make things simpler. So please go to the front of this sheet. Back to here. Let's take a look at this. All right. We've got this big algebraic expression here, and our goal will be to take it and simplify it. Now, I'm going to be drawing some things on this. If it helps you, I would encourage you to do it with me. If it doesn't help you, then I guess that's fine. But first of all, I want to look through here, and in order to make things simpler, I look for like terms, terms that have the same variables, including powers, actually. We should probably add that. For example, I see right here a negative 2x. If I look along this string here, what other terms are part of the x family? This one is negative 4x. This one over here, negative 15x. Now the squared x's are not, because that's the x squared family. They're their own type of terms. But I can now combine these terms. They're called like terms. So here we go. Negative 2x minus 4x is what? I would get negative 6x minus 15. Negative 6 minus, that's negative 21x. Okay, that's what I just got out of that. Now I'm going to look for some other family members here. I see some numbers that don't have variables. I could look at those. For example, positive 3, positive 5. Notice I'm including the sign in front. Terms include the sign in front. Positive 11, negative 15. They are all like terms, same family. So let's combine them. 3 and 5 would make 8, plus 11, 8 and 11, 19. 19 minus 15. That would be a negative 4. So we combine all those, we get a negative 4. Right. All right, so what's left? Well, we have those x squared terms. This one is negative 4x squared. This is positive 2x squared. Again, notice I included the sign in front when I said the term. That's part of the math. So here we go, negative 4x squared plus 2x squared. Negative 4 plus 2 is negative 2x squared. All right, this right here is called simplified. Simplified. I can go no further because these are not like terms. They're different families, different types of terms. I can't combine them. Now, you might be wondering, is that the order you have to list them, Mr. Smith? No, you can list terms in any order you want. For example, in textbooks, you'll usually see it like this. You'll see the ones with the highest power first, and you'll see the ones that have variables. The variables are usually alphabetically ordered, and you'll always see numbers at the end. So again, I just rearranged these, as you can see, but it means the same thing. I'll try and write it more like a textbook would, but this is proper. Any order technically would work. So next one here, let's do it together. Look for like terms. Well, I'm just going to start here. This is the x family, so what terms would go with that? Well, this one would, positive 2x. That would not, negative 9. The xy family would not be the same as just x. But this one right here would be a like term with that family. And I think that's about it. So I'm going to start with the x family here. Here we go. X plus 2x, that's 3x. Minus, whoa, wait a second. 3x minus 3x. What's 3x minus 3x? It's going to be 0, yeah, 0. So if something zeroes out, you don't even list it, because if you list 0x, whenever you actually have an x, there's really one x. So if we get 0 x's, we just don't even list it. So this is gone. Let's move on. Here we go. So I see a regular number here. I'll go to that. In fact, maybe I won't. I'll go to some more of the variable things. I see positive xy. Then I see positive 2xy. Then I see negative 3yx. Now, you might be wondering about this. Why would I include this as the same family when it's yx instead of xy? Okay, well, if you're thinking multiplication can be reordered, you're right. If you take 2 times 3, it equals 6. Or if you flip it and say 3 times 2, that equals 6 as well. So whether you say yx or xy, you're really meaning the same thing in the end. So they're still the same family. It's called the commutative property. So here we go. We got 1xy right here. Plus 2, that's 3. And then minus, wait a second. 3xy minus 3y. Okay, we got this 0 thing going on, so nothing there. So finally, it looks like we're left with the constant terms, or just the numbers. Let's see what those would make. Notice I'm including the sign in front. So negative 9 minus 2 is negative 11. Negative 11 minus 4 is negative 15. Wow. Folks, that is simplified. Pretty crazy how this whole expression here really can be simplified down to negative 15. Right? Now I would like you to try the last one below this on your own. So go ahead and pause this. Try it on your own right now. Now here we are. Let's take a look. How did you do on this last one? I'm going to do it fast. I got 4x, positive 2x. I see a minus 1x or minus x. That would make 6 minus 1. That would make 5x's. I'm going to go to the yz. I see that one. And I think I see the positive 2zy. They're the same family. So that would make 1 and 2, 3, plus 3, yz or zy, either way. Then I see this little guy here is all on his own, the big 4xyz. I'm going to just throw that in front, 4xyz there, plus that. What's left? I guess I have the little constants, the number terms right there. So here we go, negative 3 plus 8 is 5, 5 minus 9, negative 4. So you should have got this expression, if I'm getting my math right. You should have got this, but it might be in a different order than what I have it. Textbook, you probably see this 3yz come before the 5x, but these 4 terms. Any questions on that? You could pause it and talk as a class or keep going. So I'm going to keep going. I'm going to leave this for now. And I want to do a couple problems with you from your homework assignment. So please find this. And the entire assignment is required, so you're to do everything on this simplifying expressions for your assignment today. But we're going to go right down to 5, 6, 7, and 8 and practice here. I'm going to do number 5 and 7, and then I want you to do 6 and 8 on your own and see if you get them right. You ready? Number 5. Look for like terms. What have I got? Yeah, if you're thinking I've got n's here and I've got n's here, you're right. So I'm going to combine them. Negative 5 minus 1, that is negative 6n. Simplify. Number 7. I've got this expression. Looks like I have more than one of the p family here. Notice I have p and negative 6p. Don't forget the sign in front of the 6. That is 1p minus 6. p, 1 minus 6. That's negative 5 with p on it. And then the 9 is not a p member, p family, so it just stays around. And that's as simple as I can go. You cannot add and subtract unlike terms. I could also list this like this. I could put those terms in different order. I got positive 9 in this. Either way would work. So there you have it. All right, please pause and try 6 and 8 on your own, and then we will check them. Okay, here's number 6. I saw the r's right there. So 4 minus 6r is negative 2r. And you got a positive 7 still hanging in the front. Or 7 could be first, and then you could have the minus 2r be second, but it's the same thing. Terms can be reorganized as long as you keep the proper signs with them. This one would be negative 11n. Right, so there's an example of what we just did on those huge problems. We did the 4 on your assignment. The rest of this represents what we call the distributive property. And so let's do a few of those. We're going to go back to our notes here and write a few more things on the yellow sheet. You got all these little algebraic forms here that help us understand what distributive property is. If you understand algebra really well, you might get these. If not, I'll give you examples. For example, if I have, let's write this right here. If I've got 5 times x plus 2, I'm going to show you what this looks like. The distributive property says, well, normally you'd simplify math by doing parentheses first, adding things together, but you can't here because you can't add unlike terms. I can't just put an x plus 2 together and smash it together and think it's 2x. That means something different. 2x means 2 times x. So I can't smash those together, so instead, look what it says. Instead, I could take a times b, get a times b, whatever that is, and then I could add it to a times c. That's called distributing. You ready? 5 times x is 5x. You can multiply and divide unlike terms. You just can't add and subtract them. And then 5 times positive 2 is positive 10. So this right here is called simplifying with the distributive property. There's other examples when it's subtract. You can kind of see what happens. You subtract here, but I'll give you one more example. If I have, we'll do another one below this, negative, let's see, we'll do negative 2 times 3x minus 4. That is the same as this says, you take piece A times B, so that's this times this. So here I go. I'm going to take, use a different color here. I'm going to take negative 2. First of all, I'm going to times it by that 3x. Okay. When I do that, negative 2 times 3x is 6x, and it's negative 6x. And then I look at the other term in the parenthesis, which is a negative 4. And I would go negative 2 times negative 4. That would be a positive 8. So I simplified by distributing or multiplying. Again, this involves a lot of multiplication. Multiply or times. Distributing is all about multiplying things out here. Okay, so that's what we're doing. So let's do a couple examples from the assignment, and then we'll stop and go a little further. So here we go. Back to your assignment. And oh, by the way, sorry, go to this one for a minute. I went ahead and filled this out. I figured you wouldn't have so much time, but I did a whole bunch of distributive property examples. I would take an expression, for example, this one, and I would say, what number are we sharing or distributing? It's the one in front. And I showed you what I was getting when I distributed. Then I also showed you what it would mean in that same line to combine like terms. If you get stuck on distributive property, I want you to look back at this sheet and see if your problem you're stuck on looks like any of these examples that I have done for you. And then see if you can apply what these examples show to your problem on your homework. And the teacher that's with you, I'd like them to also point you to the sheet. If you're stuck on this stuff with parentheses, go to this sheet. Is there an example that looks kind of similar? Can you see what I've done? Use this little help sheet that I've already filled out. If you're a little unsure what distributive means. Okay? So back to our assignment. We've got to complete every problem on here back in front. Let's start some. So number 1, we're going to go, first of all, we look here, normally we would combine in the parentheses to follow order of operations, but you can't because they're not like terms. We just have to leave them. So instead, we are going to distribute. So this means multiply. Remember? Multiply right there between the parenthesis and that number. That's multiplication. So here we go. Negative 3 times the first term. And the first term is negative 10b. So that would make positive 30b. Okay. Now we're going to go negative 3 times the other term, and the other term again is negative 3 right here. Negative 3 times negative 3 is positive 9. So there we go. Now I can't combine those. They're not like terms. That's called simplified. I'll do some of the odds with you for now. Number 3, negative 6 times positive 9. Let's see, that would be what? Negative 6 times 9. Negative 54. Good. And negative 6 times negative 6n would make what? Negative 6 times negative 6n. That would be positive 36n. So look at, there's one way. Now I forgot to write both. Remember, we can switch order. So on number 1, you could say 9 plus 30b. On this one here, you could say 36n in front and then the minus 54 in the back. It'd be the same thing. Okay. Maybe try 2 and 4 on your own if you want. Actually, we're going to keep going. Do some harder ones, get through a few harder ones with you. Give you some confidence there. So let's skip down to these ones, like 9, 10, 11, 13, these ones. I'm going to skip to problem, let's do 9. If you look at number 9, you have a couple things going on. Not just multiplication, but here you got -8 minus something in front. But in order of operations, you always do the multiplication before you add, subtract. Because we're not solving anymore. Remember, we're not finding n or x. We're just simplifying things. So I'm going to take this and multiply -6 times n. That gives me -6n. And then I'm going to go again, and I'm going to go -6 times -10 right there. And that's going to give me what? -6 times -10 is positive 60. So I'm getting positive 60. Okay, better make that a little more clear. Get positive 60. All right. And then this little -8 is just hanging out in front, so I just bring it down, and it stays in front. Once I do that, I have to always be saying, can I make things simpler? Well, if you're thinking yes, you're right, because I see a -8, which is just a number, right here, and then I also see a positive 60. So they're just both regular numbers without a variable. We can combine those two terms together. Here we go. -8 plus 60 is positive 52. So I would be left with -6n plus 52. Or I could put the 52 in front and -6n, either way. I like to write variables first usually. So, okay, I'm going to pick up the pace. We'll do a few more. So let's skip to number 13. Number 13, you're going to go -4 times 4x. That would be -16x. And -4 times positive 1. It's -4. And then -2 is sitting around at the end. All right, so now I look at these and I say, do I have any like terms? I think I do. I've got -4 minus 2 there. That would be -6 if you simplify those two. I get -16x minus 6, or -6. You don't have to write both, but one or the other would work. -6 minus 16x. All right. Okay, now let's see here. Why don't we hit number 15 maybe? And we'll do a couple others here. Actually, we can do 15. Sure, we'll do 15. There we go, number 15. And if you're getting this, you can go ahead of us. This is just me trying to get you guided through a few things. So first thing, we're going to take this -5, and we're going to multiply it by the two terms inside the parentheses. -5 times -7k is positive 35k. Again, I don't need to know k here. We're not solving. We're just simplifying. These are expressions, not equations. Not solving. -5 times positive 10 is -50. And then I've got this little -3 in the front. It's just still sitting there. Okay, here I go. I'm going to see if I can combine some like terms now. I've got a -3 here. There you go. And a -50. They're both regular numbers. So -3 minus 50 is -53 plus 35k. There we go. There's our solution. Or if you prefer k in the front, I actually like it that way, but textbooks do it more like that. It's more common to put the variable first. Okay, that's 15. I'm going to cruise on and do a couple of the biggies on the back, and then we'll call it good, and you're on your own. Okay. Now the nice thing today, I do have a Socrative that you could punch in all your answers to this. If you'll take a look at the side whiteboard, the room name, you just get on Socrative.com, right? So you're allowed to pull out your phones at this time or earlier, as long as you're only on Socrative. So teacher, they know about this. They should only be on Socrative.com or the app. And you enter the room name, which is your class period. You can see it on the board. And you can start entering your final answer on all these. I just ask that when you put in your final answers, you're not going to put any spaces. You just write it out without spaces. So I'm on 21. So here we go, 21. Negative 8, let's see, is going to be multiplied by these two terms. I'll keep highlighting to emphasize. You don't have to do that, but it might help if you kind of boxed or maybe circled the things. If you're not seeing what really needs to be multiplied and stuff like that, it helps to do some symboling. Hopefully you've drawn a few arrows on your notes to remember what's going on and put multiply or things like that to remind you what's going on. So negative 8 times negative 5n. That's negative 40n. Negative 8 times positive 7, it's positive 56. Then I go to here. Positive 10 times 8n, it's positive 80n. Positive 10 times positive 3 is positive 30. So I got a big long expression, so I say, can I make it simpler? I see n family here, I see it here, and I see it here. I'm going to combine those two. That would give me negative 40n plus 80n would be what? Positive 40n. And then I see 56 with 30. So 56 plus 30, that would be 86. So 40n plus 86. So if I'm putting that into Socrative, I could put either one of these, but I just go 40n plus 86 without any spaces. And it should let me know if it's right or wrong. But just don't use spaces if you want to check everything on Socrative. Socrative will be also opened until the next time I see you. So if you wanted to check it over the weekend, take it home. If you don't finish this, Socrative will still be open to plug in answers and check. And you'll be able to use it until we meet again, which will be on what day? Tuesday for you guys? It'll be on Tuesday. All right, we're getting there. Couple oddballs here. Let me just get to those before I forget. If you look at problem, where is it? One like number 19. Let's look at that. Number 19. Sometimes we see this little minus and we think, what in the world is this little floating ghost minus doing here? What does that mean? Okay, if you're thinking, well, Mr. Smith, you can just simply rewrite this and put a negative 1 by that minus. You're right. That's one way to look at it. You could say negative 1. Or you could just leave it a negative and say, what is a negative times a positive x? Or you could say, what's negative 1 times positive x? Well, you would be getting a negative x, right? And then you could do that again and say, what's negative times negative? So I'll use pink here. Try that again. What's negative times a negative 4? Well, negative times negative is positive. Or negative 1 times negative 4. It's positive 4. So basically, I get this when I distribute. Then the little 4 in front, I bring it down. Okay? I combine the like terms. I see two 4s here. 4 plus 4 is 8. So my final answer, negative x plus 8. Or I could put the 8 in front, the positive 8, and the negative x behind. Either way works out. Okay. I'll do one more. I'll hop over to 22 since it's up on the screen there. So number 22, again, I'm going to distribute. First, I see this times this and this times this. So yeah, here we go. 9 is going to be multiplied by those two things. That would be negative 9 minus 90k. And I go to my next group. I've got positive 2 times k. So that's positive 2k. All right. And then 2 times positive 6, positive 2, that's positive 12. I look for like terms. Let's see, I've got a negative 90k plus 2k. Negative 90 plus 2. That piece right there would take us to negative 88k. And then I see I've got these variables to emphasize in orange here. Negative 9 plus 12 is positive 3. So I could simply say positive 3, or change it like this, positive 3 minus 88k. It's kind of how things work. So look, you've got some work to do. You've got your desk partners by you. You can use Socrative, start punching in from the beginning, Just go in order 1, 2, 3, 4 into Socrative. It'll help you out. This is due the next time we meet. Please use the rest of the period to work. Look back at your notes. Teacher, point them back to the notes if they forget how to distribute. Right? Try and look back at these problems. See what you can do. Good luck, and we'll talk to you next time.